I am back with a new video, a new tutorial, this time on writing professional looking documents with LaTeX or LaTeX, however you want to pronounce it. And if you're completely new to this, what LaTeX basically is, it's a tool where you just write in plain text, and that allows you as a writer to just worry about the actual content that you want to write, and then LaTeX will take care of all the formatting for you. So LaTeX is capable of doing that because it provides us with a set of functions or commands that we can use to tell what we actually want. Like, do we want bold text, italic text? We want a section here. This is a new chapter. We want a new line or a new page over here, a title or whatever. So we're gonna take a look at all of that in this video. At least the basic stuff like basic text formatting, generating lists, tables, and also inserting images. And then I will have additional videos as well where we take a look at generating a bibliography and managing them with LaTeX. So that is what we're gonna do. Now, if you want to use LaTeX locally on your machine, you do need to install a text distribution or a LaTeX distribution, basically a LaTeX compiler, to basically have your plain LaTeX document compiled to your desired output, which is most likely a PDF. So if you go to latex/project.org, you can go to the page, or you can just copy this link URL from the description box, and then just go to the instruction for your operating system, and then just go from there to install it locally. Another solution is to just use an online LaTeX servers like Overleaf or Papeeria. That allows you to just use LaTeX online without installing something locally. Now, if you do choose to install LaTeX locally, you do need a LaTeX editor, and this is a list of probably a lot of popular LaTeX editors, but I guess the most popular one is TechMaker. That's what I see a lot of people use when I started learning it. So you can try this one. If you happen to be a programmer that uses VS Code, you can use VS Code as well with the Text Studio extension, if I'm not mistaken. So you don't have to install any additional text editor for LaTeX, as long as you have the LaTeX distribution installed for your operating system. Now, I'm using NeoVim for writing LaTeX, but it doesn't matter. You can still follow along because it's just plain text. So yeah, that's what we're gonna do in this video. So I'm gonna navigate to my terminal here, where I'm already in the article directory. If you have never seen a terminal in your life, I'm basically inside of my article directory here, but this is just a text based interface for it. Now, what we can do right away is create a new LaTeX document. So just create a new empty file and then call it whatever you want, but as long as you have the .tex extension. So like that. I'm going to call it paper.tex. I also prepared a image here that we will use later, or I'm going to use later to show you how you can include images. So yeah, I'm going to close this and then open it up with NeoVim. So paper.tex. Okay, so this is we just have an empty file here with the .tex extension. I'm gonna set some, do that. And the first thing that we want to do to create a LaTeX document is tell what kind of document this is, and we use the document class function for that. So function in LaTeX is created with called with the / followed by the function name. And then as an argument for a document class, we say we want an article. So that's the most common one, but you can use book, report, and a bunch of others as well. We're going to take a look at a slight difference in this video as well when you have a book or a report when you're structuring your document. But let's go with document class article for now. And then what we need to do is begin. a document environment, and then also end it. So whenever you begin and end something, this is basically creating an environment inside of LaTeX, and this is the main environment where we will be writing in. So this is where all of our text goes. So we can write something like, this is a paragraph in LaTeX. Now this is a special function that I'm using right here, the LaTeX function. That's basically to just have this, what is this? This typical LaTeX logo, I guess. I have no idea what this is, a way of writing LaTeX. But yeah, that's not that important. So I save that, and then you need to compile it. And if you are using overleaf or another text editor, you probably have a button somewhere at the top that allows you to recompile it. I have a key binding for that, and it is, yeah, so like that. Yeah, so now this is the PDF output inside of my PDF viewer, and this is what we have here. So this is a paragraph in LaTeX, and this is our output. Now, the font size is a little bit small, so what we can do is add an argument to our document class using square brackets before our curly brackets. So I want to increase it with 12 to 12 points. So we can just do it like that. And if we save it, it will recompile, and then you can see we have a slightly increased font size. Okay, so yeah, this is really the basic layout or structure of your LaTeX document. This is what you will need for every LaTeX document, the document class and the beginning and the document environment. Now, this here above the document environment and in between the document class function, this is called the preamble. And the preamble is used to, for example, importing packages. So LaTeX has a lot of packages that you can use, and also to add some custom configurations for your document. This is what you can use for the, this is what you put in the preamble. So we can take a look at that later, so like importing a package. But yeah, so let's take a look. Yeah, so let's play around with paragraphs a little bit more. Now, if you are inside of your text editor, so let me copy paste this line and say this is another sentence in LaTeX, and then I save it. It will recompile automatically. You see that even though I have it on a new line here inside of my text editor, it will still continue the paragraph in the output. And that is because when you want to create a new paragraph inside of LaTeX, you need to have a double return like this. So if I copy this, and yeah, like that, I save it. It's not really that obvious right now, so let me actually do it like this. Yeah, you can see that the indentation basically is how you see that this is a new paragraph. And to make it a little bit more obvious, I'm going to use a package here to generate some dummy text. So to import the package, you use the use package function inside of the preamble, and we're going to use the blind text right here. Let me delete. Let me delete this. And then call the blind text function like this, and then a new paragraph. Yeah, so this is a little bit more obvious. So this is our first paragraph, and this is our second paragraph. So make sure you have a double return, or like a double enter, whenever you want to create a new paragraph inside of your document. So yeah. Now, another thing that you probably want inside of your document is a title and the author name and perhaps the date as well. Now for that, we can use the make title function. And if we save it now, it actually won't output anything useful yet. It does generate the date for us automatically, so October 12th. But the LaTeX compiler does provide us with a warning here, so no title given and no author given. So in the preamble of our document, we can use the title function. So we can say learn yeah, learn LaTeX in, I don't know, 30 minutes perhaps is what this video is the time that I will use in this video, or how long this video will take. I have no idea. Author, let's use my full name right there. Save it, recompile, and then you will see that the title and author is displayed right there. If I actually don't use this, the make title, it won't show. So we need the make title function there. So yeah, as you can see, the date is generated automatically for us. If you do want to set it manually, you can call the date function here and then say something like year of the monkey or something like that. So yeah, if that's something that you desire, you can do that. I'm just gonna let LaTeX handle that for us. So yeah, the next thing that we can take a look at is some basic text formatting, like bold text, italic text, and so on. So you can do that with, so yeah, this is normal text like that. But if we want to have some bold text, we can use the text bf function and then say bold text. And we can also have text ID, which is for italic text. We can also have underline for underlined text. And then we can also have quotes. So quotes, you can use the backtick. So like this. So let's use double backticks and let's say this is something someone said. And then close it with the double quotes as well. I save that. And now as you can see, we have the opening quote notation and the closing here at the end. And you can also use single backtick. So this is another thing someone said, and then close it with a single quote. So like that. Let me actually make a new paragraph for that. Yeah, so like this. So yeah, those are just some basic basic examples of formatting your text. Another thing that you can do with LaTeX is add headings, which are called sections inside of LaTeX. And you use the section command for that. So this is a level 1 section. And let's say formatting here. And here's when we used paragraphs. Yeah, so as you can see, I spelled paragraphs wrong, but it doesn't really matter. So as you can see, we have 2 sections or headings right here inside of our document, and LaTeX also automatically takes care of the numbering for us. You can also, if you just want to get rid of those numbers, you can add an asterisk here, or what is it, a star symbol. And if I save it, you can see the numbering goes away. Okay, but let me get rid of that and put the numbering back like that. So yeah, that's something that you can do. Now, besides the level 1 section, you also have subsections. So subsection, let me put some blind text there as well. Blind text. We have subsections, subsection, subsection. You can call it blind text as well. And then, yeah, that's the one that you probably will use the most. Section, subsection, and subsection. If you have a report, like a thesis, for example, you will most likely use the report document class. And usually you will have chapters as well, and therefore you can call the chapter function like this. So let's say something like introduction. If I save that, yeah, you can see that we have this chapter 1 introduction, and LaTeX will take care of the numbering for us as well. If I would use article right here, As you can see, it wouldn't work because LaTeX really doesn't know what to do with chapter inside of an article. So yeah, that's something that you can use as well. If you use book document class, there's also something called part, like part, I don't know, intro or whatever. So I changed the document class to book here at the top. And you can see the output of our document has changed as well. What is going on here? Yeah. So we have part 1 intro, an empty or blank page. Then we have chapter 1 introduction and all the stuff that we did earlier. But yeah, let me go back to article and get rid of the part and intro, recompile. Yeah, and this is what we have. So this is some of the basic stuff that you can do with LaTeX. Yeah, so let's take a look at some other stuff, basic stuff like I'm going to create a section here. Let me actually do this at the top so it's a little bit more readable. Lists in LaTeX are also pretty simple. To do that, we create an environment, and you have two types of lists in LaTeX, ordered and unordered. So let's create an ordered list first with the enumerate environment. Now, everything that you begin, you also need to end, like that, and then we use the item function, and then actually specify the item here. So let's say Python, for example, a programming language, Java, and Rust. Let me save that. Now, as you can see, this is our ordered list right here. So I'm gonna actually create a subsection here, ordered list, and create a new subsection called unordered list. Now, for that, we need to create another environment, and this time for an unordered list, we can use the itemize environment. And then just call the item function as with the ordered list, and then let's say C++, C, and I don't know, Haskell or something. Save it. And that's our unordered list. So really simple, easy. I think it's pretty straightforward as well. Maybe if you're completely new to this way of writing, it needs some getting used to, but it's nothing difficult. Now let's take a look at tables in LaTeX like this. I'm gonna create another section here at the top. And to create a table, we also need an environment, and we're gonna use the tabular environment actually. Tabular. I forgot to add a backward slash here. And then here is basically where we define our table data. So to create a simple cell or column, we just write something like this, cell 1. And then to create the second cell on the same row, we add the and symbol, cell 2. So now we have two columns, and then add another one, and then now we have 3 columns. Now if you want to create a new row, you tell LaTeX that you want a new row by using these two backward slash or forward slash, backward slash. And another thing that we need is the tell LaTeX the alignment of our columns. And so here where we start our tabular environment, we add another set of curly brackets, and then we can, for example, do L, L, and L for left align. And then if I save this, you can see we have our table right here, but without any borders. So let's add some borders here with the hLine function, which is basically just a horizontal line. So now we have some borders. Now let me actually create another row so you can see it. And so now we have 2 rows. We can, of course, add another horizontal line here in between. So like that. And you can also choose to add some borders here, horizontal or vertically, where you define the alignment with using the pipes like this. Now if I save that, you can see we have borders horizontally and vertically. Now usually what you want to do is have some captions and also the ability to reference your table. So to do that, you wrap your tabular environment inside of the table environment like this. So let me indent that. Now if I save this, nothing really happens as of yet, but you can see that the default behavior of the table environment is to put it at the bottom here of our page. You probably also want to center your table. You can use the centering command or function right here. And then we can use the caption function to add a caption. So this is a table, something like that. And you can see LaTeX will also take care of the numbering here. So this is table 1. And then let's say this would be a research paper. I would say something like in table, and then I want to reference it with the ref function. You can see a table function. You can see a table in LaTeX. So like that. Now, to be able to reference it using the ref function, we do need to create a label. So let's say tab and then table 1. So yeah, for tables, I like to use like tab and then double colon and then the actual name of or something that is easy for me to remember when I want to reference it. So like, let's say table 1 for now. And if I recompile this, you can see here in table 1, you can see a table in LaTeX. So it's referencing this right here. So that's pretty neat. Yeah, so those are tables. Let's take a look at images, so figures. And to be able to insert images, we do need to import a package. So I'm going up to the preamble again, called the use package function. And then what we want is the graphics package. Use graphics like this. So graphic and then X. So not an S, but an X. Now we can also define the path of our where all of our images or figures are saved. So I have my images inside of the figures folder. So this is relative to our current file. So /figures. So LaTeX will now automatically search for images there whenever I want to include an image. So to include an image, we can call the include graphics function after you imported the use graphics package, and then we have fish. And now fish comes from this right here, the name of the actual image. You can see it does have a JPEG extension, but when we include it in our LaTeX file, we don't actually need to specify the actual extension. You can just omit it. And I think it's actually best practice from what I've read. Something that I forgot to mention as well is that whenever you compile LaTeX, you have these additional files here, like the .aux, fls log, synctech.gz, and yeah, some of them are basically for LaTeX to easily like reference the tables here, because every time, for example, when you recompile LaTeX, it doesn't know about, for example, this table when it's still here, but using, I think it's in the auxiliary file, this one, or the FL, I can't remember, or the synctech. because I haven't really remembered it, but perhaps I will search for an article where you can read more about it. But it's basically for LaTeX to store some information about your document. Not really that important for now. So let's take a look at our figure. So I included it. If I save this, now we see that we have an image right here, but it's not visible at all because the image is too large. And to actually make it fit our page, what we can do right here, where our include graphics function is, we add square brackets to add some arguments. So we, for example, want to customize the width. Let's say we want it to be equal to the text width, like this. And now you can see that our image fits perfectly within the document. Now, just like with tables, you are also able to caption it and reference it. So for that, you need to create an environment as well. In this case, the figure environment. End it as well, like this. What I like to do is just make sure that it's centered as well. And then we can add the caption. So this is a fish. And then a label. Now, like with tables, you saw that I like to use tab. For figures, I like to use fig. And then fish, for example. And then I can easily reference it this in figure and then ref. Now I can reference the fish figure and so whatever here. Save it. Yeah, now you can see in figure 1, which now is here. You can see because we use the figure environment that the positioning has changed. But that's our image right there. And this is where we reference it. So yeah, I think that's all the basics that I want to show for now. Perhaps something that you want to, there's one thing that I would like to add as well, and that's taking a look at some basic math typesetting. So like I haven't used math a lot for my LaTeX document because I haven't written anything that is that requires a lot of math. So but what you can do is, let's say subsection, you have two modes to display math. One is inline mode and display mode. So like that. With inline mode, what you can do is, for example, say this is some equation, and then use the $sign to basically write your equation. So let's do something that everyone knows: E equals mc squared, and then just end it. And now you can see this is some equation. So as you can see, LaTeX can really create beautiful equations on your paper. So this is inline math. You can also, so if I copy this, just 3 ways to basically write inline math. The other one is this way, if I'm not mistaken, like this. So let me double check if that's correct. So as you can see, this is also still inline math. And then the final one is like this. So you create an environment, begin, I think math. I think it's math. And then end math, like this. Write and save. And you can see that the output is still the same, even though we use a different way of writing it. But so those are some examples of inline math. I do have a bat math environment delimiter. Whatever, I don't really know what that means, but perhaps this. No. So probably here, there's something wrong here. Okay, so yeah, okay, not really important. As I said, I don't really use math a lot. I'm not really great at math, but this is just to show you what is possible. So yeah, display mode. We can create the begin equation environment. Equation. And then let's go with the E equals mc squared again. And now instead of having it inline, we have it at the middle of our page. And then also it automatically numbers it. So this is equation number 1. If I would have another begin equation and equation, and I would, for example, have another super complex equation here, like that, you can see it automatically numbers this for us. So yeah, that's pretty great. I'm not sure actually if you can also caption it. So that's something that you probably can look up somewhere online. But yeah, that's something that you can do. One thing that I want to show you, if you need to use math a lot, what you can do is detectify. Yeah, this one right here. Yeah, so let's say you want to use some kind of math notation that you don't know the actual LaTeX command. What you can do is, I don't know, something here. And LaTeX will try to search for, the actual symbol that you want to use. Whatever, and it's pretty good as long as your drawing is not too weird. So yeah, you can use this to search for your math symbols. Yeah, I think that's it for this video. I have shown all the basic stuff. Yeah, and that took me about 30 minutes. But yeah, so in the next videos, I will show you some more stuff, like bibliographies mainly is what I will be focusing on. And also, I will have a separate video for those who are interested in using Neovim as their LaTeX editor. I will show you how you can set that up. It's not really that much work, but something that you might be interested in. So yeah, hope you enjoyed this video. Hope it was useful. And yeah, don't forget to leave a like, subscribe, and also leave a comment. Perhaps give me some ideas for another video, because it actually has been a while since I created a video. But yeah, so thank you, and bye bye.